This video is for Modern Chemistry 2 at Carnegie Mellon University. It's a very brief introduction to Excel, especially to prepare people for doing the homework on kinetics. I'll start off by adding some numbers to this column. I'm just going to make up some numbers. And so that's one thing you can do, is put numbers into a cell. Another thing you can do is put formulas in. Formulas start with the equal sign, and then you can put in a reference to that, which is column A, row 1, so A1. And now I'll copy that, and when I paste it, you can see that it's referring to the thing to its left. So A1 actually meant move over one column but stay in the same row. And we call this relative indexing. To show more about how this works, let me add another set of numbers. I'm just going to type in some numbers I like here in column C. Once I have that row filled in, I'm going to copy the formulas I made in row B. So I'm selecting all of column B and I'm pasting it into column D. And you can see that now everything points to the number 1 to its left. So it's another example of relative indexing. And I can put in more complicated formulas, like here I'll add B1 plus D1, and I'll multiply it by 3. And this is a way to quick copy and paste. By dragging that lower corner down, basically copying the formula into every cell in that column. When I go up here, I have a nice color scheme, so I can see that what I'm really saying is go 2 over to my left, take that blue value, add to it the red value, and multiply by 3. As I move down, the cells I'm referencing move down with me. Changing this to 7.2 changes all the cells that reference it as well. Next, I'll show how to use a plot to investigate data. Here, we'll see if y versus 1 over x leads to a straight line. So I'm just typing in some text labels so I'll remember what's in my columns. And in this column, I'm going to put in a formula for 1 over x, which is A2. I'll drag that down, so I copy that formula to the entire column. And I'm just going to plot this with y. So that column will just be y copied over again. And now I select those two, and these will become my x and y for a plot. Go to Insert. From Chart Types, select Scatter. So there's a nice scatter plot. And now I'll right-click on a piece of data. It'll bring up a menu for me. And I'll add a trend line. And there's different formulas for the trend line. Here I'm just doing a linear fit, so I'll have a linear line. And I'd like to see the formula for that line, so I'll click Display Equation, and I'll put in an R value. The closer R is to 1, the better the fit. You can see here graphically that this is not a very good fit, and that's reflecting in the R value being quite different from 1. So it's also convenient and easy to transfer things between Excel and Word. Here I'll add a note to my chart title about my conclusion that y versus 1 over x leads to a very poor model. It's not a good correlation. Save that. And now I can select this graph, hit Control C, then switch over to Word, scroll down to where I want to put it into my report, and paste it, and resize it. And so this is a convenient way to summarize results. Now for this homework, we give you tables of data, and I can come down here and select that table, and copy and paste it over into Excel. So Control C. In Excel, I'll make a new sheet. So I have a new workspace, and I'll paste it in. Looks good. And now I'm going to put in a column for the experimental rate. And let's say that I think the rate is supposed to be column F divided by 1,000. It's not, but I'm just showing you how you would go about it from the Excel perspective. And I'll fill that column in. So there's all of my experimental rates, incorrectly calculated. I'll go back to Word, and in this homework, your goal is to derive a rate law. So let's say that I think the rate law is supposed to be some number, let's make something up, 12.3 times the ozone concentration times the oxygen atom concentration squared. And now I'm going to test that. So I'll go back to the spreadsheet, and I'll say, here's my predicted rate. I'll put in 12.3 times, from that column, the ozone concentration for experiment 1 times oxygen concentration squared for experiment 1. And that's my predicted rate. Just looking at that, I can tell that I'm pretty far off, but let me calculate the error in percent. So I'll take my predicted rate minus my experimental rate. Again, all using references. Colors let me know what numbers I'm typing in. So percent error will be that value divided by experimental. The difference divided by experimental times 100 to get into percent. And I can pull down in order to copy that formula into the entire column. And if things were working, I should have a relatively small percent error. Here, 10 to the 28% error is pretty bad.